And good afternoon, everyone. Thanks for joining us. My name is Zach Allison with ATS for another one of our ATS University sessions. If this is your first time joining us, thanks for giving us a shot. Hopefully, we provide you some value-added info here. ATS University is a program put on by ATS Spec Tool, and if it's your first time, you're probably unfamiliar with Spec Tool as well. Spec Tool is an amalgamation of manufacturers that come together for an online configurator, helps you find exactly the model name and number that you're looking for. And we are a free design platform for those in the design community. It's paid for by the manufacturers, which means that we get the most up-to-date information. If they change the model number or discontinue a product, we're told in advance so we can help keep your projects and masters up to date. A big part of what we do as well is make sure that not only are you getting the right suffix and the right options selected on your products, you're also understanding where and why those products are used. And that's where our ATS University session comes in. So we run a wide array of these presentations covering application-specific deep dives where we might walk through, say, a stadium or an airport or healthcare and long-term care and talk about the types of products that are used in those types of applications. We'll do sizing focused discussions, whether it be water heaters, sump pumps, PTAC coolers, everything in between. And then we'll also do code focused discussions that are more generic. Then we get into kind of our nitty gritty, which is, like a discussion like today where we're reviewing code and product and how they go together. Correct me if I'm wrong, Mark, is this an ASPE accredited presentation or is this just generic content?
Uh, Generic content.
Perfect, which fits the Canadian audience. So this is a product that's focused on in the Canadian environment for us, but of course we do specs both across North America, so US and Canada, and even some international ones. But with the out reporting in Canada, we will send your certificate of attendance so that you can self-report these for your CPD hours. So we help out a lot of our engineers all across Canada getting those hours throughout the year with these webinar sessions. So this is the short intro to ATS, our spec tool, and our university sessions. I'm going to be mostly moderating the chat and keeping an eye on any questions that anyone from the audience raises today. As with all webinars these days, the attendees are going to be muted upon entry. But if you have a question on anything that Mark talks about, then you'll be able to pop it into the Q&A chat, and I will bring that up to Mark when we get to a breath or in between slides. So yeah, with all that, thanks for joining us today, Mark. I'll let you kind of introduce yourself, but I always, whenever I'm talking to you, I just call you the guy that knows everything about PEX pipe.
Yeah, thank you very much, Zach. Hi, my name is Mark Barwood. I work for Reliance Worldwide Corporation, and I'm an area manager. I look after Western Canada, so from Ontario to the West Coast. I've been in the plumbing industry for around 30 years, worked for quite a few different manufacturers, and I'm in my third year at RWC. So Zach asked me to do this presentation on PEX, and here we go.
Let's dive
So
in.
the presentation, the way it's structured, I just want to talk about codes, standards, and authorities that have jurisdiction, AHJs.
Oh, we had our first little technical difficulty. It seems like Mark, did something happen on your end? It looks like the screen sharing stopped.
PEX fundamentals, uh, what PEX is, how it's rated. We're going to talk about Canadian standards, so ASTM, CSA, NSF, and different fitting systems. We're going to speak about connection methods. And then at the end, I'm just going to do a quick little slide on the specification checklist. So RWC in 1 minute, Reliance Worldwide Corporation. We are an amalgamation of a lot of different companies. So a lot of people might know us as Cash Acme or SharkBite. HoldRite is another company we own. And also we own John Guest, which is from England. So we've brought all those brands together under one umbrella. And even just to give you a little insight with PEX, our complete PEX system is called SharkBite. And I know a lot of people know SharkBite as our push to connect fitting, but SharkBite is actually the whole piping system and the connection methods. Our company has a job site focus. So all our solutions support new construction, repair, and remodel in residential and commercial settings. And then lifecycle control, RWC does a lot of their engineering and design in-house, and we see the product right through the design to the manufacturing stage to on shelves at wholesalers. And our motto is delivering smart solutions that are the first choice for plumbers. So why do codes and standards matter? So just to know that there's lots of product standards. So a product standard, for instance, will be ASTM F876, which is like the granddaddy of everything to do with PEX. It encompasses stuff like dimension and tolerances of PEX, pressure ratings, burst pressure, hydrostatic sustained pressure testing, chlorine resistance, UV resistance, degree of cross-linking, environmental stress cracking resistance, and then also how the pipe has to be marked. Everything to do with PEX is ASTM F877. In Canada, we've adopted that and we call it CSA B137.5. It's very comprehensive, but in itself, just because it's a standard doesn't make it a code. When it's referenced by the actual plumbing code, then it becomes relevant. People have to adhere to it. So if they speak about how connections have to be made in that ASTM standard, then the plumbing code will reference the standard. So that's the difference between standards and codes. Nothing is code until it's actually referenced in the plumbing code, and then it becomes the law. Another thing that pops up from time to time is the authority that have jurisdiction. So the local authority that has jurisdiction interprets and enforces the adopted code. For Canada, always confirm with local amendments. I run into this once in a while where the guys on the East Coast, they have some really wild ideas on different things. BC can be a little different. Now with the harmonized plumbing code in Canada, I think it's going to get a little bit better and it'll be more similar right across the country. But in certain areas, we have some inspectors that have their law unto their own, and it's always good to know if you're designing a job in that jurisdiction to know the nuances. So PEX system can be technically strong and still fail if a submittal if the listing, standard reference, or application is unclear. So just something to think about as well. And then what specifiers and inspectors actually need to see. So you need to know if PEX is going to be the right material. So just a quick distinction. I know a lot of times we use the name tubing and pipe inter alia, like we don't think is a difference, but PEX should always be referred to as tubing because we adhere, PEX, the SDR9 standard is copper tube size, CTS, and that's why push to connect fittings work. They work on copper pipe and they work on PEX because both materials, both tubings have the same OD. So PEX tubing is the correct term, not PEX pipe, but I know we do use them similarly, but the actual correct nomenclature would be PEX tubing. Another thing you're going to want to know if it's in a building, is it listed for drinking water? So you're going to need NSF CAN 61 and also NSF 372, which the difference between NSF 61 and 372 only references the lead content where potable water is involved. And then, is the application covered? Is temperature a factor? Pressure, UV exposure, if it's going to be in a plenum, or if it needs fire and smoke rating, if it's going underground, or is it an in-slab condition? you have to know if that pipe is good for those applications. And then, is it tested to the correct standard? So in Canada, CSA B137.5 is always going to be the standard, but a lot of times ASTM F876 will also be referenced. And is the correction system approved? So part of PEX is how are the connections made, and then you have to check the tubing fine print for compatible fitting standards such as F1807, F1960, F2080, or F2159. And I'll go over those a little bit later again, but just know there's lots of different connections we can use with PEX tubing. So when you're specifying a pipe, you're also going to specify a connection method. Quickly, PEX fundamentals. So I've been selling PEX for years. I was like one of the first guys around when PEX made a comeback, sort of in the late 90s, early 2000s. Up until then, we were using polybutylene, and polybutylene failed spectacularly. There were class action lawsuits everywhere. And I remember somebody telling me back in the late 90s that PEX was invented to run fiber optic cable under the ocean. And then when I was doing this presentation, I just went to go verify that that little piece of information, and it turns out it wasn't actually true. So for years I thought, hey, we invented PEX to run fiber optic cable between the continents, but that's not true. So in plain English, PEX starts as polyethylene and is cross-linked. A good way to think about it is if you take your two hands and you hold your right hand over your left hand at 90 degrees. So in normal polyethylene, all the fibers are running in the same direction. And then if we use a method to cross-link them, so we excite the fibers, and then 50% of the fibers go in a 90-degree angle, and then that cross-linking is actually what gives us the strength. If you're interested, you can probably find a video on YouTube that will explain that a lot better. And then common applications for cross-linked polyethylene: water service lines, hot and cold distribution lines in buildings. Radiant heating is a massive one. In cooling lines, snowmelt, hydronics, geothermal loops, and selected fire protection applications, mainly residential. We don't see it too much in commercial. And then why specifiers care about specifying cross-linked polyethylene? It allows for very flexible layouts. It's corrosion resistant. There's way fewer joints, so fewer leak opportunities. It has much quieter operation than copper because it's not rigid. And then joining options are also way more. We have way more joining options than copper would have. And then again, I just want to reiterate, used tubing are referring to most North American plumbing PEX because it is copper tube size CTS, or SDR9 is the actual standard. And it's based on OD of pipe. Not quite OD. It's not like a refrigeration pipe where they say 3/4 OD, and if you measure it, it's exactly 3/4 OD. But the SDR9 standard talks about the OD of the pipe. Okay, so just a quick history on PEX. PEX was invented in the 1960s, and it was actually invented by Thomas Engel. So if you hear about PEX A, they talk about it's the Engel method. So the original inventor of cross-linked polyethylene was Thomas Engel, and he invented it using PEX A, which we'll get to in a minute. And then in about 1972, PEX started getting used for radiant heating systems in Europe. And I think, like with a lot of things in plumbing, North America, we kind of, a couple of years, we're always a little bit behind Europe. It seems like Europe are always on the cutting edge of technology, and Canada kind of lags behind, or North America lags behind. I find that's my personal feeling that I get. And then around 1984, they wrote the ASTM F876 standard and F877, and it was published in North America. In 1989, CSA B137.5 was first published in Canada. And today, PEX is widely used I always joke with new housing plumbers, and I say, when last did you guys see a house plumbed in copper? And they reckon, hey man, if you want to build a custom house and you want it plumbed in copper, you're going to pay a significant extra amount of money for that, because they go, we don't even know if we can still do a house in copper. Like we may not even have the skill set to do that, because these guys, they just run PEX. All the high rise buildings now in the suites, everything's PEX. It's just it's so much easier to work with, and it's faster and it's more cost effective. Something that is like a misconception in PEX. A lot of people have been led to believe that there's three different kinds of PEX: PEX A, PEX B, PEX C, and A is the best, B is second best, and C's the worst you can get. And that's not really true. So when we talk about PEX A, it's just how the cross-linking was achieved. So PEX A, they use peroxide. They inject peroxide into the polyethylene, and that starts the cross-linking. And then they also throw the pipe into PEX A, they don't. PEX B, saline PEX. So saline is mixed with polyethylene. That excites the fibers and achieves the cross-linking. And then PEX B also has to be put into an oven and baked afterwards as well. So PEX B actually has a higher burst pressure than PEX A. So in a lot of cases, PEX B, in some ways, superior to PEX A. I don't really have a dog in the hunt. We make PEX A. RWC makes PEX A. We make PEX B. And we used to sell PEX C, and that's sort of coming to an end. So PEX B has a higher burst pressure than PEX A, that's for sure. And it also can tolerate a higher chlorine concentration in water than PEX A can. So in a lot of cases, PEX B is actually superior to PEX A. PEX A is a lot more flexible than PEX B because of the way it's cross-linked. There's pluses and minuses all across the board. PEX C is the latest PEX that's come around, and its extruded tubing is irradiated after extrusion. So they use like a laser beam to achieve the cross-linking. And surprisingly enough, PEX C is turning out to be some pretty good pipe. So even though it's late to the market and a lot of people see it as like the third-class PEX, it's actually not bad pipe. So those are the three kinds of pipe. Just remember, the A and the B and the C are how the cross-linking was achieved, and it's not a grade. Not A is the best, B is second best, C is the third best. It's just how the cross-linking was achieved. All still PEX. In this industry, I think manufacturers spend way too much time actually fighting against each other, instead of saying, hey, you know what? Let's all band together and be unified PEX and talk about, the real enemy or our biggest competitor is actually copper. So it's not, I'll never bash any other manufacturer. I think, we should all be together more and be selling PEX, talking about the positive things in PEX, not about, I'm better than this manufacturer or that manufacturer, which
I guess
has
not
always been a
surprising.
kind of weird thing for me.
Yeah, not surprising. This is kind of where some of our questions are coming up in the chat so far. And I'll kind of summarize it. Like, it sounds like you said there's some positives and negatives, some benefits and subtractions for each of these different manufacturing methods. How do you know which one is the right to use? Like, is it an application specific approach where, you mentioned burst pressure on PEX B. Is that then better for, different applications versus the flexibility that you might get from PEX A?
So Zach, traditionally PEX B was used more in residential. PEX B was more widely available originally in the early 2000s, when PEX really started taking off in Ontario, basically the whole of Canada. There were no PEX A. Well, I guess Uponor made PEX A quite early. They used to manufacture it in Saskatchewan. I just think that PEX B was more widely available originally.
Mm-hmm.
So it got used more in low-rise residential construction. PEX A sort of differentiated itself, and they went after the high-rise business very aggressively.
Yeah.
Came up with a couple of new ULC standards, S101, S102, which I'll speak about a little bit later as well. So I think we see different PEXs in different places. A lot of contractors tell me they prefer using PEX A because it is more flexible. I've started to see some of the new home, the residential plumbers in Toronto have started using PEX A. There's plus and minuses and everything. It's
A bit of
good to be
preference,
aware that there
user
are
preference,
different
maybe.
grades of PEX. So there's different kinds of PEX. So is PEX A good for every installation? In some cases, yeah, maybe it's true. PEX B don't have some of the S101, S102 designations, so you're not going to be able to use them in a fire and smoke spread application or in a plenum. And PEX C mainly I see in heating applications. I don't see a lot of that in potable, but if it's approved, you can use it.
Well, that kind of brings us up to a bit of a follow-up question, getting a little bit more specific on the applications. And you might have just given away the answer. They're specifically asking for where you are looking for a higher pressure, higher temperature type systems like high rise, and specifically on the hydronic systems. Is that then you just mentioned that maybe that's a better PEX C? Is that more, is there any reason that you would lean to one of these over the other for hydronic applications?
Well, hydronic applications. When you say hydronic, you mean in-floor heating? Is that?
Uh, they didn't clarify, but I would
Okay.
imagine that it's likely in-floor heating
Because
or
for any heating application, you have to use an oxygen barrier pipe. So they put a coating on the outside of the pipe, and then oxygen won't be able to permeate into the pipe. Because obviously we know in a closed loop heating system, oxygen is the devil. It's going to corrode all the boiler, the components, everything in the system. So we try and get all the oxygen out of the system. So if the pipe is able to let oxygen through, you wouldn't be able to use it in those systems. So heating pipe is always oxygen barrier. So it's something different than potable pipe that I'm mainly going to talk about. I don't have heating pipes, so I'm not going to spend a lot of time talking about it. But just to know that if it is a heating application, that's going to be oxygen barrier pipe,
okay.
which
Perfect.
I didn't spend a lot of time in this. I mean,
No
I'm
problem.
talking more general about PEX, not really getting into the real nitty gritty. But I'd be happy to answer questions. But to know in a heating system, it's going to be oxygen barrier pipe.
Perfect. And last question, is PEX-A approved in Ontario for ceiling plenum application in terms of smoke and flame ratings? I think you probably get to maybe those smoke and flame ratings later, is what you said. So
Yes.
we can wait for that if you want.
Yeah, not every manufacturer is approved. So you have to make sure before you specify something, you're going to have to go to their website, download a spec sheet. I'll tell you a quick little story. I was on a job site a couple of months ago, and I saw a contractor was using a pipe called PERT, which is a polyethylene pipe manufactured in Canada. From everything I hear, it's good pipe. It's not actually PEX, so it is PERT, something a little different. And I said to him, "Hey, how are you allowed to use this in a high rise?" And he said, "Well, it's got S101, S102 approval." And I went, "Oh." And I was pretty sure that I'd been told they didn't have that approval. So I went on their website, and sure enough, right on their spec sheet, they said S101, S102 approved. And I was like, okay, so I had bad information. And I went back to the person I got the information from, and he said, "Yeah, Mark, did you read the fine print?" So in their approval, it says that if it's outside of the wall, it has to be insulated. And I said to the contract, I called the contractor back. I said, "You're going to insulate that pipe when it penetrates the wall?" And he goes, "I don't need to, Mark." And I'm going, "Yeah, but according to their approval," he says, "Yeah, but the inspectors don't really know about that." So,
That's great.
Yeah, but we have to really pay attention because a lot of people have approvals, but it's only if the pipe is insulated. So the actual insulation is giving you the approval, not the pipe. So it's good to be aware and just ask questions. You can get hold of the manufacturer and say, hey, send me your S101, S102 approval. It's just you got to pay attention. It's a minefield because some people have some approvals and not others, and some pipe has that and not others. So you really have to do your due diligence to find out. You have to do your own homework basically to see who's
Well, and,
approved for
and
what.
speaking of doing the homework, I wouldn't wouldn't be doing the job if I didn't use the your reference there for a shameless plug. You mentioned checking out the manufacturer's website. I'll also say that the spec sheets for all the products on the ATS spec tool are embedded in the spec tool. You can check all your ratings. You can look in the detailed spec sheet as well as in the features that are available on the spec tool, and then configure your selection right there to get exactly what you need. So there's my
Yeah.
shameless plug for now. I'll show
I
you.
mean,
I'll show you how you can do it even at the end of the presentation.
you take the guesswork out of the job
Yeah,
because you've already done the work behind the scenes.
that's the goal.
Yeah. Okay. Really neat. Glad that synergy worked out. So I think one of the questions that were asked about hot water, we're starting to see in certain condos now in Toronto. I'm hearing stories about, uh, you know, we had this with copper on recirc lines. Copper was failing, pinhole leaks all over the place. A lot of that was attributed to not the greatest water quality, the velocity of the recirc pumps was too high, and now we're starting to see some cracks developing with PEX. Just know there is a certification. It's called PEX 5306, and those numbers actually mean 5 is chlorine resistance. The highest number is 5. So any number lower than 5, 4 would be a lower rating. 3, 2, 1, 1 is the worst. Uh, the highest UV rating is 3, and then anything 2 and 1 or lower. 0 would be no UV rating, and then 6 is a hydrostatic design basis. So it's tested to a burst pressure of 630 psi. So on hot water recirc lines, you want your PEX to have a 5306. Now, some manufacturers are getting around that by saying you can't recirc the pipe for longer than 12 hours at a time. So they want you to shut off your recirc pumps for 12 hours a day. And they think that's going to save their pipe. So just know that there's a designation, and some manufacturers are going to limit you to how much you can recirc the pipe, how often, how many hours a day you can recirc the pipe, the water for. And obviously, temperature is a problem. So at any time polyethylene gets, the hotter the water, the lower the pressure rating is. And anything bad that happens with PEX, I find, is when the pipe is overheated, when the water in the pipe is too hot. It's a problem for sure. So the first digit is chlorine resistance. It's intended for hot chlorinated water exposure. The second digit in the 306 is the UV rating, and the last digit is the hydrostatic design strength pressure rating class. So that is specifically for hot water recirculation certification. Just quickly, sustainability. So PEX is way lighter than the traditional piping would have been copper. I mean, PEX comes in 250-foot rolls. I've seen plumbers carry 3 or 4 of those at a time. A plumber couldn't carry 250 feet of copper easily, around job sites. So because it's in coils, it's so much easier to work with. It's easier to handle on job sites, and just moving the pipe around is so much easier than traditional copper. And then system efficiency. I don't know if you guys have ever looked at PEX pipe under a microscope. The walls are completely smooth, so we don't have the water becoming turbulent inside the pipe. If you look at copper under a microscope, it's like a road in Toronto. It's lots of little speed bumps and lots of divots in the pipe. So when water flows inside copper, it becomes turbulent just because the walls aren't as smooth. So you can achieve way better flow out of PEX than you can out of copper. And then durability. PEX is resistant to corrosion, and selected disinfectants when properly specified for the application. So just know what you can and can't put. What if there's certain things in water you won't be able to use PEX, and you'd have to go to a different material. Okay, Canadian standards and listings. So I think I mentioned earlier ASTM F876 was sort of the first standard in North America. It's an American standard. ASTM actually stands for American Society for Testing and Materials. It's very widely referenced, well known. Lots of people know about that standard. ASTM F877 is specific to PEX hot and cold water distribution systems, and that includes the fitting system. So the way the pipe reacts with fittings and how fittings work with pipe is the F877 system. So in Canada, we mirrored ASTM F876. We called it CSA B137.5. And basically references everything that ASTM F876 referenced. When we went to lead-free plumbing systems, NSF or ANSI CAN 61 was the standard to which all plumbing systems are rated, and if anything traveling through that pipe is going to end up on a human being or be ingested by a human being, it has to be NSF 61 compliant. And then also on top of that, we have NSF and ANSI 372, which is the lead content requirements for drinking water systems and components. I'm not going to spend a lot of time on that. I think it's been covered. It's been around since 2014. It's been code since 2014. So I'm pretty sure everyone has a fairly good understanding about NSF 61 and NSF 372. So what PEX tubing standard actually tests? So the F876 does test. There's a tolerance. The pipe has to be within a certain tolerance for OD, wall thickness, out of roundness, copper tube size, and its SDR9 consistency. Pressure capabilities. I'm not going to get into the specifics now. There's another slide a little bit later on that tells you the actual specific pressure capabilities. But pressure, just know that pipe gets tested. It gets tested in a lot of different ways. They test pipe until it bursts as well, so they do no burst pressure of pipe. It gets tested at temperature and / pressure limits, and long-term hydrostatic strength as well gets tested in labs. Potable water durability, so oxidative resistance to chlorinated hot water and stabilizer functionality. Weathering, because it's plastic, there has to be a UV inhibitor in pipe. So any pipe that gets installed outdoors, in the early days, PEX wasn't UV stabilized, and we used to warn people, hey, don't leave it out in the sun too long. So just know that pipe has to be UV resistant, and outdoor exposure is not good for PEX. Material controls, so density, degree of cross-linking, workmanship, and marking requirements. Those are all things that are referenced in the standards. And then use-specific ratings, flame and smoke spread, oxygen barrier for in-floor heating, hydronic or service line standards where the application requires. So a lot of times when they use PEX for water service, they have to put a copper piece of copper wire has to be adhered to the plastic pipe so that it can be picked up if they ever have to look for that pipe with a locator. So before you dig, you have to get the locator guy out, and if there's no metal on that pipe, you'd never be able to pick it up with these equipment. So just know there are some different pipes for water service lines. And we start seeing a lot more PEX there now as well as copper gets too expensive. Okay, so pressure and temperature ratings. This is just a standard. Some manufacturers can do way higher pressure. Like I've personally been in labs where I've pumped PEX up to 1,000 psi, and PEX B generally ruptures around 1,000 psi. So a rating of 160 psi at water temperature of 73 F, that's 23 degrees C. Sorry, I know you guys all think metric. I still think imperial. I grew up in a country that was metric, and then I came to Canada and I got imperialized. So anyway, both scales are yeah. Hot water, like I said, as temperature increases, pressure rating will decrease. That is plastic in overall, universal for all plastics. So on hot water at 180 F, PEX is only rated to 100 psi. So 690 kilopascals, 82 degrees C. That's pretty hot water, 180 F. Typically, you don't see a boiler firing at more than 160 unless it's a medical application. But residentially, in the high rises, boilers are firing at 140 F. And a lot of designs I see, the mixing valve is after some of the PEX. So it has to be able to tolerate at least 160 degree F. And a lot of manufacturers are saying you shouldn't put higher than 140 degrees F to the pipe, and that it wouldn't be warranted. I have seen a little bit of that lately. And high temperature would only be rated 80 psi at 200 F, and that's very hot water. So 550 kilopascals at 93 degrees C. If anybody wants a copy of that slide, I'm sure Zach will be happy to send it to you, but it's in the standard anyway. It's quite universally available. So dimensions of PEX tubing. So like I said before, it's a copper tube size. CTS is copper tube size, and the standard is SDR9. The tubing OD is generally 1/8 of an inch larger than the nominal size. So if it's 3/4 inch pipe, the OD is going to be 0.875. So I said it's a little different than when we talk about pipe size. It's normally internal dimension, not the OD. And in refrigeration copper, it's all in OD. So that's why I'd say it's important to call PEX tubing, because it's a copper tube size and SDR9 standard. So PEX pipe uses NPS, iron pipe, or other piping sizes. So we do talk about like 1/2 inch, 3/4, 1 inch, 15 millimeter, 19. I can't remember. I always have to Google it to go back to millimeters in size. But and then why it matters: codes, fittings, and product markings are written around the sizing system. Confirm copper tube size versus iron pipe size. And in North America, all PEX is made to a CTS standard. So I'm not even I'm not that worried about it. But if pipe is coming from a different jurisdiction, so maybe Europe or Australia or somewhere different, just make sure that it does conform to the CTS standard. Flame and smoke. So if pipe's gonna be running in the plenum, it's gonna have to be CAN-ULC 102.2 listed. In return and Plemons. This is a standard that came around that I said differentiated PEX B from PEX A. PEX A, one of the manufacturers came up with this standard and precluded all PEX B. Like a lot of people, it was very expensive to go do the testing. It was a flame and smoke spread test. Cost a lot of money to do. And a lot of PEX B actually didn't pass the test, and too many changes would have had to be made to resins to actually get that approval. So a lot of manufacturers that made only PEX B, they didn't see the value in going to get those certifications. And that's why PEX A sort of took over the condo market, because they had that S101, S102 standard. And that was one of the big differentiators. S102 talks about fire resistance of an assembly. So it's like a 1 or 2 hour rating, the same way we rate access doors. So if it's a 1 hour or 2 hour rating, S101, And S102, S102-2 was a flame and smoke spread. So the 50-25 rating is the S102.2. So in a plenum, you need S102.2, and that's a smoke generation number or certification. So with looking at, like I said, I was on a job site and there was PERT. Guy told me it was rated S101, S102, and I looked at their spec sheet. Sure enough, they had that approval, but in brackets they said, see the asterisks. Looked at the asterisk. They said pipe outside of the wall has to be insulated. So even though they had the standard, it was actually the insulation that was making them pass that standard. And most contractors, they would never insulate the pipe. It's going to be too costly, too time consuming. They're never going to go back and insulate it. So if you're specifying a high rise, make sure that the pipe is actually 101 and 102.2 rated without insulation. Just quickly, PEX wouldn't be PEX unless we talk about connection methods. So just quickly, the most common PEX connection method was always crimp. So it's a copper tube that goes, the fitting gets put inside the pipe, and then the copper tube is on the outside, and they use a crimp tool to make the connection. It's been around the longest. I think people trust it. The standard for that is the F1807 or the F2159 or the F2098. Cold expansion, which generally we hear of cold expansion, was where a machine is put inside the pipe is expanded, the fitting gets put in with a extra collar, and then over time the pipe expands, comes back, it has memory, it comes back around the fitting, and that's how the connection's made. So the pipe is expanded and the fitting's put in. So we commonly see that on angle method pipe, PEX A. There's some PEX A manufacturers that will allow you to crimp their pipe. RWC is one that says if you want to crimp our PEX A, we don't have a problem with it. Heatlink allow you to crimp their pipe. Uponor does not allow you to crimp their PEX A. They have a different classification of PEX now that I think is still PEX A, and they allow you to crimp it, but it's only residential, doesn't have S101, S102, but I can't really speak to it that well. Just know that some manufacturers will allow you to crimp PEX A. It doesn't all have to be cold expansion. Cold expansion, some contractors don't like it. If you working in a building that doesn't have any heat in it, sometimes when you expand PEX A, it takes forever to come back. If it's freezing cold, like -30 or -40, I've heard it takes weeks to come back around the fitting. So if you want to do a job in PEX and pressure test, you're going to wait for that pipe to come back around. A lot of contractors wouldn't love that. So the flexibility of being able to crimp PEX A is a plus for a lot of people. Push to connect, which is like our traditional shark bite fittings. Uponor also came out with a push to connect line recently. That's governed by ASSE 1061 and also CSAB 137.5. They are around. We don't see them get used that much in commercial plumbing, really. More of an emergency kind of fitting, and then people go back later and change that. And then PEX Press is something that Viega came out with years ago, and they discontinued it in Canada. They still have it in the US. And RWC just very recently launched PEX Press in Canada. So we're back with PEX Press. And I think one of the reasons we launched PEX Press is to say that we have all those connection methods. And we're the only manufacturer that has every kind of connection method there is for PEX. And there's one very slight caveat to that. Rehau, which is the manufacturer of PEX A pipe, they have a very unique connection way of expanding the pipe, and it puts the fitting in at the same time. If you guys have never seen it, it's worth gonna take a look at it. It's something very different. It's a very unique machine to have, and that's governed by F2080, which is a little different from F1960, but they're the only manufacturer that uses it. It's not approved for anyone else's pipe. But besides that crazy system, we have every other kind of connection method when it comes to PEX. Just quickly, a little visual. So on the left-hand side top it was mainly used on PEX B. Fitting gets inserted into the pipe. The copper ring gets put on the outside of the pipe, and then there's a crimp machine. There's another kind of fitting as well, made by a company called Odica. They had a stainless steel clamp that you used kind of like a cinch tool. Not very widely used. I don't see it much in Canada at all, really. So I just would mention it that it is available. A lot of PEX A, the preferred method would be expansion. And like I said, some manufacturers will allow you to crimp PEX A as well, but others don't. So know the expansion. The expander is put inside the pipe with a collar on the outside of the pipe. The pipe gets expanded, the fitting gets put in. In hot weather, it comes back pretty quickly. In cold weather, it takes forever. PEX press is like copper press. The fitting and the collar are one piece. The pipe gets put in. There's a little window on the fitting to see the connection that the pipe's in all the way, and then you can crimp it. There's a hand crimper, but most contractors have a battery operated machine. When you look at PEX pipe, there's a million different, lots of writing on PEX pipe. I just want to demystify a little bit of that in my next slide. Okay, this is a little easier to see. So if you look at this pipe, so it says it's SDR9 potable tubing. I'm looking at the white pipe on the top side. It says it's ASTM F876 F877 approved, F20 2023 and F8 180, F1960, F2080. So that tells them that pipe can also be expanded. It's probably PEX A. So if it can be expanded. So you can, if you know what all those designations are, you can sort of tell a story that tells you what that pipe is good for. And that has to be on the pipe. That's part of the ASTM F876 standard, or the CSA B137.5 says what has to be on the pipe. If it's plenum S101, S102.2, that'll also be written on the pipe to say it's approved. And that just helps inspectors, contractors, if you see some PEX laying around, hey, can I use it in the plenum? You're going to look for that certification. I mean, generally, it doesn't happen that somebody's just going to grab a piece of random pipe, but all the PEX on that job site, contractors will know what's there and what it can be used for. And then as a specifier, you have to know what you're specifying for. So if it's potable water, do you need recirculation designation? Is it going to be UV exposure? Is it going to be in a plenum? Is it underground? Is it in the slab? Is it going to be used for fire protection? And then if it's hydronics, it may acquire different listings.
So just before we finish up here, because we've got about 10 minutes left, we had a great question come in that I really want to kind of hammer home. I think the certifications that you were just going over, looking for hot water recirc applications, and understanding how the PEX tubing degrades, or like how it fails, and then specifically whether or not chlorine exposure, temperature, other factors, does it lead to brittleness, the burst that we've seen in some of the videos that go around online, micro cracks, pinholes. Like, how does it fail, and how does it work best for what should they look for to work best in hot water recircs?
So, like I said, you want that 5306. That's the highest designation. So it has the highest chlorine resistance, and it's been tested at the highest burst pressure. Like I said, a lot of manufacturers are saying that they won't certify their pipe if the temperature on the recirc line is going to exceed 140 degrees. And you go, well, that's fine. We have mixing valves. It's never going to exceed 140. As we know, mixing valves fail and pipe gets overheated. Boilers generally don't fire at a higher temperature than 140, but 140, sometimes you see it go up to 150. Just depending on designs, the way recircs work, there can be a net heat gain because if 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 a building isn't well piped or the mixing valve's failing, on a recirc return in a mechanical room, you're gonna send back a percentage of the water back to the heating source if the water's too cold, and if the water's too hot, you're going to send 100% of it back into the recirc. So if you keep recircing pipe and it's a closed loop because no water's getting used, eventually that water will cool down because there's no way to reintroduce more hot water into that line. It's become a closed loop overnight. I used to say to contractors years ago, hey, when water's recircing at night, just shut the pump off. There's a condo developer in Toronto. I don't know if anybody does designs for them. Tridel. They were one of the first condo developers to actually put a lot of building automation into their buildings, and their building automation system. One of the things they look at, one of the matrices they measure is how much hot water gets used after 12 o'clock at night up until 5 o'clock in the morning, and they tell me very emphatically it's zero. So if you shut the pumps down for those hours, you're probably going to be okay. You might have to turn them on an hour before the first people shower, just so you have some hot water in the line. But a lot of times we can overcome stuff just by turning the recirc lines off. It's just another way to skin the cat. But on that recirc, 140, they don't want to see 140 degrees exceeded. And then we can't control the chlorine level is going to come from the municipality. We can't really control that. So things to know about for sure. So just quickly, the specification checklist and the practical. So what is the application? Like I said before, we've covered this: potable, hydronic, service line, fire protection, geothermal, underground, in slab, or if it's going to be in a planet. And then the material standards that we have to adhere to. Canada's always going to be CSAB 137.5. Some jurisdictions before the Harmonized Plumbing Code or the Unified Plumbing Code in Canada, they might have referenced ASTM F876, basically the same thing. It's for tubing. 877 references the fittings, and CSAB 137.5 would be tubing and fittings. Does it have a potable listing? So is the pipe NSF 61, NSF 372 compliant? The performance code is the material designation code for chlorine resistance, UV resistance, and pressure rating. Connection method, you have to specify how the pipe has to be connected. We've gone over those connection methods. And then installation methods. So temperature and pressure limits, supporting and spacing, bend radius, protection from abrasion, and UV pressure test method. So in a lot of condos now, it's all metal stud. When you go through a metal stud, you have to actually have a grommet that can protect the pipe. If not, the metal will cut the pipe and we're going to have a leak. So all those things have to be specified as well. Just very quickly, so installation details that affect approval. Bend radius, every manufacturer has a measurement on how much their pipe can bend. Lots of manufacturers make different supports that can go on pipe. Worthwhile using those. If you spec them, then they have to get used. And then support spacing, you have to follow manufacturer's instructions and adopted code. Obviously, for hot water, it has to be braced more frequently than cold water because the pipe will droop more when it gets hot. Protection from abrasion, sharp edges, nail, screw damage. So you have to use nail plates or screw plates everywhere with this PEX, because when you put that drywall screw in, it will pierce the pipe. Pressure testing, local code, how pipes tested after it's installed. Is it tested with water or with air? And you have to follow the accepted procedure, and then thermal movement. As PEX heats up and contracts, as it heats up and cools, it changes dimension slightly. So sometimes when you're in a house and you hear like wee, wee, that's the PEX pipe expanding and contracting, and it's rubbing on a wooden stud, and it's like somebody's playing the violin in the background. Uh, so if you ever hear that noise, just know that the PEX is expanding and contracting. Just quickly, RWC, our value proposition is we control the complete life cycle of our product. Over 50% of what we currently sell in North America today is manufactured in Cullman, Alabama, in our own facility. And we've just very recently opened a factory in Monterrey, Mexico. And our goal is that within the next 5 years, we're going to make 75% of what we sell in North America is going to be made in North America. That's what we're shooting for right now. So we do all our own innovation. Our engineering is done in-house. All our certifications are done. We do our testing, raw materials. In a lot of cases, we own the factory where our raw materials come from, or we have a very good working relationship. I mean, during COVID, our fill rates were in the high 90s because we controlled our own supply chain. We never had a problem. We manufacture all our own material, and we control our supply chain, our marketing, and customer service, the last touch we have on our product. Just know you're dealing with a quality organization. I feel immensely fortunate to work for RWC. I think it's a very good company. And that's it for me, guys. Just 3 quick takeaways. Don't grade PEX by letters. So like I said, A, B, C doesn't mean good, better, best. It's just the way it was cross-linked was achieved. Standards and codes work together. Standards define product performance, codes and authorities that have jurisdiction govern allowed installations confirm local requirements. They do change a little bit from place to place. And then compatibility is visible. The tubing, print line, and product listings are fastest way to confirm approved fitting systems and use of conditions. I think we've already covered questions, but if you have any questions, shoot them over now. If we don't get to them all, then I'll be happy to, if you send them to me, and then I will get your answers back.
For sure. Yeah, there's a couple of questions. I'm going to rock through this demo really quick so people can see what we were talking about today and how they can find the info, and also show how they can find the recording of this session.
How can I stop sharing?
Yeah, I think it should be on my screen share now.
Okay.
And we'll come back to, there's a couple of additional questions that we'll circle back to in about 10 minutes. I'm going to go through this really quick. I mentioned at the beginning of the program, ATS Spec Tool, atspec.com. Head over to the site. It's free for all those in the engineer design community. The main goal is to help you find the right product, make sure that you have the right options and suffixes and your model numbers all up to date and accurate. We've integrated the ability to include, any other brands now. So I asked a question during there about a poll about whether or not PEX is included in people's masters if they need help. One of the big things that ATS Spec does is builds a version of your master, your internal standards on the system. And then because we are paid for by the manufacturers, we can help keep that up to date. You, as the owner of that master, get a notification when, let's say, RWC updates, their PEX piping starts getting the S101, S102 that we were talking about, or there's a change to the model number, change to the nomenclature. You, as the owner of that master, which reflects your internal standards and ties into those internal documents, it's not replacing them, it ties into them. You'll get notified that, hey, this water heater's had an update to their model name and number. Hey, this product's been discontinued and has been replaced with this one. There's a ton of work that we're doing right now is meeting the new NRCan Amendment 18 updates for flow rates on faucets and showers. And if those products are in your masters, you're getting a notification from our team telling you, hey, your master, which includes this product that is no longer applicable because of this code update, here's your new recommendation, or meet with Zach to get the right recommendation. That's what I mean when I say the masters on our system is let us help keep your internal standards and processes up to date. And if you want to learn more about any of those products and features on the spec tool, if you want to learn more about any of the products that are on our spec tool, you can go to this architects and engineers tab over to our webinar recordings. And all the products from Pipe Month have been added in here. We had questions on corrosive waste and chemical applications, sizing, to watch and review the presentation to get today, which I've been through a number of PEX presentations over the last 10, 15 years. And I think that was one of the more detailed code focused versions that I've ever had, and great application focused discussion. So that can be found here through the Learning Hub, webinar recordings, and then you can log in and get your system set up to suit you and your firm. So we talked masters really quick. Masters is, created here. There are permissions around who at your firm can control the master, edit the master, because again, the goal of these masters is to update your internal systems while also providing some unique features that allow for more rapid selection on the actual spec tool. And then your day-to-day jobs, if you're just looking for a simple pipe spec, or Mark mentioned the pipe support from HoldRite. If you're looking for that, we could go into HoldRite, create a quick spec. It's a simple title. There's not much that's needed here. We are not selecting location. We're not selecting application. So this is really just a generic selection. There's no rule engine applied to this. But we can go in, find the product we want, configure the selection, get the updated model name and number, see all the key features of the product, see all the certification it passes, see the manufacturer's spec sheet, which is embedded into the system for every product that's on the tool. So if you're looking for dimensional drawings, if you're looking for, pump curves, if you're looking for recovery rates on water heaters, et cetera, those might all be found in the manufacturer's spec sheet. And if you're looking to configure the selection, that's available right here within the system. Just hit add product and then you can go to download. But I referenced, the rules engine. So a rule engine is applied based on locality and application. So your region, Ontario is going to have a different rule engine than BC, which is different than Alberta, which is different than uh, Nova Scotia, Quebec. And the other piece I'll mention, especially with the NRCan updates, there's exclusions for things like healthcare applications. They have different flow rates now allowed than a generic office application. So that is going to be tied into our building engine our building class rule engine. And the last thing I'll mention is the bid date. If I select October 10th, then those same updates to the model name and numbers are going to be applied up until October 10th. So your master stays up to date, for as long as we can. Your project stays up to date up until the bid date that you select. The bid date obviously is a flexible thing in our world. Submission changes, deadlines change. We can go back and help you edit to make sure that a project from 2024 maybe has come back around. We need to review it, make sure it's still up to date. We can help you with that, no problem. So I've already created this RWC PEX piping. We've got a selection in here. Let's show you again. We went through the category selection, which is this method here, where you can go in, filter down by any of these options, chemical resistance, pre-resistant, combustibility, manufacturer even. We can configure our PEX-B piping if need be. Once we add a product, we get the fixture chain, which promotes any additional products that are needed. So if we were doing, say, a plenum rating, this might come with installation for those types of products. But we'll go back to the project. The other key part of masters which I really think is a difference maker They work the same as our templates. So this is our quick access drawer. You have ATS templates, which is basically ATS's recommendations. And then you have your master. So you can share these across your firm. So your BC firm can be working with the same drainage or pipe or water heater master, sump pump master as your Ontario office. Your EIT can be working off of your pre-approved selections for what you as the expert know should go into the high rise or the low rise. And it might have slightly different selections. And these are all going to be kept up to date the same way that we keep our templates up to date. And then when you want to bring that master in or the products from the master, we just check the boxes. We need our supply and our waste pipe. We need identification. Maybe we need hangers and supports. And we can either hit this to import all the selections, or we can grab the dots. We'll just drag and drop those 5 products from our approved selections into our application. We can do the same. We've got Class C office where maybe you need now the rest of your fixtures. You can grab all your fixtures or grab a couple, get some toilets, some lavs. And now in a matter of seconds, we've got our piping master, we've got our drainage master in, we've got our fixtures master in. As much or as little as within your scope is available to be selected, embedded into the system. So when I'm talking about masters, this is what I mean. Provide your team the efficiency of using them on the system and provide yourself the ease of updating your internal standards. I know that those things go out of date, and every single January, someone gets assigned the task of, hey, let's go through this massive work project and make it up to date. And by February, we've realized how far behind we are on this task. And by March, we've given up because now the project volume has overtaken us. Let us build it for you as a master on the system. You'll get notifications when the products are going out of date, have a major update, anything like that, and provide your team the efficiency of navigating them on the system. So if your team is already on it, which a number of people are, the last thing I'll mention here, this bar kind of hides it, but our download spec button is here. The spec assist button is here, which is going to assign your approved alternates. But we'll just talk about the download spec button here. If you want questions on the spec assist, let me know. And then we can download our formats that we need: long spec, short spec, CSI 3-part spec. These are just different types of Word formats. We have the manufacturer spec sheet embedded in, the submittals embedded in, Revit files embedded in, schedules available as well. And then those look like this, where you've seen likely our selection formats before. I'm going to again move this bar. So there's our PEX pipe spec at the beginning, gives us all the words and details, all the standards that we need. That same information is available in the manufacturer spec sheet format, nice table of contents. This is great when you're trying to do a review against submitted shop drawings. That's generally what I use this format for. And then I've got the long spec open here, which again gives you all the appropriate codes and standards, verbiage that you can simply copy and paste. All of our formats are open and editable. Just copy and paste directly into your internal written documentation. And if you're saying, well, we use a performance and then list out the brands, that's where our CSI format falls. And if you want less information, then maybe it's more like our short spec format. All these different formats, all freely available. Just check the box, hit the button, and then get what you need. So that's the goal of the system. So when I'm referring to the ATS Masters program, that's really what I'm referring to, is let us help you keep those internal standards up to date, and let us help your team more efficiently select on a job by job basis. And if you want help getting those put onto the spec tool, reach out to myself, Mo, Mel, Andre, any of my team. We'll meet with you and help get those updated on the system for you. If you would like to review your verbiage around PEX piping, then we can set up a meeting, and Mark or the RWC team will join our ATS squad to make sure that we are providing you all the information you need. I know there's a handful of additional questions there that we'll kind of run through as we wrap up, but I recognize we're already a little bit over. So we'll let everyone else go that wants to, but for those that want to stick around, we'll answer some questions here shortly. Thank you all that for joining us today. Thank you, Mark, for your time and great information. And if you need help, feel free to reach out. We're here to help get your spec tool up and running. Have a great rest of the day, y'all. Bye for now.